Hi class, in this video I'm going to cover some of the major points that were embedded in the questions that I'd sent to you earlier on in the week. What we're going to cover today is we're going to cover engine components, we're going to cover the 4-stroke cycle, and we're going to cover valve train operation. In engine components, I'm going to show you the main parts of the engine here. So we'll start from the top bottom. This silver component here, so above this black gasket, right up to here, is our cylinder head. Cylinder head houses all our valves which allow air and exhaust gases in and out of the engine. In this particular engine, it also houses the camshaft to operate these valves. This piece above it is called your cam cover. In older vehicles, it's known as your rocker cover. The purposes of this is to keep oil in and dirt out. This also has your oil fill cap. So when you're needing to put oil in your engine, you put it in through the cam cover. Underneath the cylinder head, we have this blue section here. This is called your cylinder block. The cylinder block houses the pistons, the cylinders, the crankshaft, and conrods. Underneath this, we have the sump. The sump here stores the oil for the engine. This is then picked up, passed around the engine, and lubricates all of the moving components inside. Now I will cover the 4-stroke cycle. In the 4-stroke cycle, we need to start inside the cylinder block. You can see here pistons moving up and down in a reciprocating motion. So the motion of them travelling up and down. This reciprocating motion is no use to drive the wheels of a vehicle. We need to turn this reciprocating motion into a rotational motion. And this is done by rotating the crankshaft through use of the con rods or connecting rods. So the piston being pushed down pushes the con rod, which in turn turns the crankshaft. This is just like you operating the pedals on your push bike. Your legs are doing a reciprocating motion up and down, and the crank on your push bike is turning that into a rotational motion. On the first stroke, we will see the induction. You will see the inlet valve here has opened, drawing air into the cylinder. As it does this, a mixture of fuel and air, created from either the injection system or the carburation system, draws this fuel-air mixture into the cylinder. Inside the cylinder, it will be a foggy mist of fuel and air at this point. Once it has finished drawing in this fuel and air, we then move on to compression. Compression is when both valves are closed and the piston rises. This squashes this fine mist of fuel and air. This creates a lot of pressure inside the cylinder, and as pressure rises, so does heat. So now we have a cylinder which is very small, which is under great pressure and great heat. This makes it ideal for combustion. How combustion happens is, we have a spark plug inside the cylinder. The spark plug ignites the fuel and air mixture. This fuel and air mixture explodes. This is also known as propagation, as a flame front expands throughout the entire cylinder. This rapid expansion of gases pushes the pistons in a downward motion. This is what powers the rotation of the crankshaft and ultimately powers your vehicle to turning the wheels. Yeah. The piston being pushed down at this point is your third stroke. The third stroke is combustion. So as the combustion expands and pushes that piston down, rotating the crankshaft, the piston then returns back to the top. But as it does this, the exhaust valve has to open when the piston is at the bottom of the combustion stroke. With the exhaust valve open, the piston can push out all of the exhaust gases that were left in the chamber. To eject these gases, when the piston is at the bottom of its stroke, the exhaust valve will open. As the exhaust valve is open, the piston rises, forcing these waste gases out through your exhaust system. That was our fourth stroke. So the four-stroke cycle consists of intake, compression, combustion, and exhaust. Now that the pistons are turning the crankshaft, we now need to find a way to operate these valves, to open and close when we need them. You can see through this belt system here that the crankshaft pulley at the bottom here rotates this toothed belt. The toothed belt in turn operates this large sprocket here. This sprocket at the top of the engine is exactly twice the size of the crankshaft pulley. So for every one rotation of the crankshaft pulley, this camshaft pulley will only rotate half a turn. So it will take 2 complete revolutions of the crankshaft to turn the camshaft once. This camshaft is operating at half engine speed. For example, at 5,000 RPM, this will only be turning at 2,500 RPM. This pulley drives the camshaft here. As the camshaft rotates, these lobes on the camshaft push your tappets, which operate your valves. Every time a lobe pushes down on the tappet, the valve opens. As you can see, this engine here has 8 valves, 2 per cylinder. Each cylinder has 1 exhaust valve and 1 inlet valve. Obviously, these need to be timed differently. The inlet valve needs to open on the intake stroke, and the exhaust valve needs to open on the exhaust stroke. These camshafts can be profiled differently. For example, if you wish to have a more performance-orientated engine, the lobes can be taller, opening the valves wider, but this does bring problems. If this happens, you will increase what's called valve overlap. Valve overlap is when the exhaust and intake valve are open at the same time. As the exhaust valve is closing towards the top of the exhaust stroke, the intake valve will start to open as well, just as the exhaust valve is closing. Valve overlap is to increase cylinder scavenging. What this does is allows a fresh fuel air mixture into the cylinder, which helps push out the waste gases into the exhaust. Because of valve overlap, technically your inlet valve starts to open during the exhaust stroke, not the intake stroke.